My name is Leo Smith. I am a student at Joliet Central High School. I'm in Mr. West Engineering Architecture 2 class, and this is my shed architecture project. So for this project, we had to do research, design, and assemble a model shed made using balsa wood. So for before we started this project, I need to do some research on Joliet shed codes as if this were like a real shed. So some interesting things that I found was that in Joliet, your shed can't be taller than 15 feet. Your shed has to be a minimum of 6 feet away from your house. Your shed has to be a minimum of 3 feet from your property line. You have to call before you dig for your shed because it's just a safety reason, just in case you dig into any pipes, because that's going to cost you a lot of time and a lot of money. And then you need a shed permit to build your shed, and a shed permit costs $65 for up to $7,000 of work, and an additional $10 per thousand more dollars worth of work over that $7,000 budget. And then the 8 items you need to start your process of building your shed are number one, accurate plat survey with placement of the proposed shed clearly marked, kind of like the one in this middle picture right here. Number two, a completed building permit application. Number three, a completed residential accessory structure form. Number four, you need measurements for your shed. Number five, you need structural drawings, brochure, or shed model number. Number six, you need homeowners association approval. Number seven, a cost estimate. And number eight, a copy of contract if work is being done by a contractor. And then I also found these two pictures. This one on the left is just a shed layout on a normal house. And then this one on the right is a shed layout for a corner lot. So these two kind of look similar, but this one's just got like a little bit more detail on what your shed has to do. So after I researched the Joliet shed codes, I researched some shed terminology just so I knew like exactly what I was working with in this shed project. And I found that a stud is a vertical support in the wall to add structure. A cripple stud is like you see right here, a short wall stud above a door and above or below a window. A header is a horizontal structural member used to support the other structural members over openings like doors and windows. A rough opening is the opening in a wall for the door or window. A sill is a horizontal wood member placed at the bottom of walls and openings in walls. A sole plate is a horizontal structural member at the bottom of the studs to hold the wall together. And then a top plate is just the exact same thing on top of the wall. So you can see in this picture, this will be a top plate, this is a bottom plate. And then a truss is an assembly of structural members joined to form a rigid framework, usually connected to form triangles. And then inside of a truss, you have your bottom chord, which is a long horizontal beam that defines the lower edge of a truss. You have your top chord, which is your horizontal member that establishes the upper edge of a truss, and then your web members, as you see in this picture. Uh, those are pieces that join the top and the bottom chords together for structural integrity. So after I did all my research, I moved on to my CAD drawings and I started with the side walls because those were the easiest walls out of all of them. And so just a note for all my other CAD drawings that the studs and like the top and sole plates are all 2 inches thick. So I started by making the sole plates and the top plate, which were 9 foot 4 inches. And then there are seven 8 foot studs that are 1 foot 4 inches apart from the midpoint of each other. And then at the very right end, there's an 8 foot stud that is 1 foot and 2 inches apart from the midpoint. So next I moved on to my front and rear walls. The sole plate and top plate for these ones were 10 feet. The front wall had 8 foot studs with a rough opening of 7 feet by 3 feet 2 inches and a 10-inch by 3 foot 6 inch header. And then the rear wall has 8 foot studs with a bottom cripple stud of 2 foot 4 inches and three top cripple studs of 1 foot 4 inches and a 2 foot 4 inch sill. And then Also, the header for the rear wall was 10 inches by 2 feet 8 inches. And then the studs were laid out as you can see uh, in these dimensions, with the studs next to the door and next to the window being like right on top of each other. And there's even spacing between the ones that are, you can see, have a longer separation in between the studs. So finally, time to move on to the trusses. So the bottom chord for the trusses were 10 feet, and the top chords were 6 feet and 4.5 inches. The angle between the bottom chord and the top chord was 30 degrees, and there's a 2 foot 7 inch middle web that goes right in the middle of the bottom chord and goes up to the top chord. And then the other webs are 2 foot 4.5 inches down from the top chords, and the middle of the webs meet at the bottom chord and the middle web. And then I just repeated this 3 times for the rest of the trusses you see in this drawing. So I did all my drawings. Now I needed to actually model my shed that would then be assembled into my final physical model. And so the first step I did was I cut cardboard to 11 1/4 inches by 17 1/4 inches. This will be my workspace for actually assembling the sidewalls and the trusses and the front and rear walls. Then I printed my CAD drawings of all my walls and trusses. I cut wax paper to fit the cardboard and the piece of paper, and this was to make it so that when I glued down my piece of wood, it didn't stick to the bottom of the paper. It stuck to the wax paper, which is a little bit easier to pull off. And then I taped down my paper and my wax paper, making sure that everything was flat. So when I like dimensioned my wood, it wasn't, like a off. Like it was perfect dimension. And then next I measured and I cut my wood using my CAD drawings. And then I glued my wood down using CAD drawings as a template for like where to glue my trusses and my studs at. And then I pinned down the wood while I was gluing just so that the wood didn't bow or move as it was drying. And then I repeated this for all the different components. So I finished all my trusses. I finished my rear wall, my side wall, and my front walls, or my front wall and my side walls. And then, so now it's time to construct my shed. So what I did was I cut my cardboard down to 11 inch by 11 inch so that could be my base for my shed. And then what I did was I found the center of the cardboard so that I knew where to put my walls so that it looked nice on the cardboard. And then I glued down my front wall, I glued my side walls and my rear walls, making sure that everything was square and nice. And then I measured and cut wood for the top plate. So there's another top plate that goes on top of all the walls. That's just to 100% hold everything together right. Just make sure that everything is structurally sound. And then I glued my front and back trusses, and then in between those trusses, I would have to glue the rest of my trusses. I had 6 trusses, and so I glued the front and back ones, and I measured the distance in between those trusses, and I divided it by 5. And the reason I did that was because there's 5 spaces in between those 4 trusses, and so I wanted to see like what the distance was between each truss. And then I just marked where the trusses went, and I glued on the marks, and then I let it dry. And so overall, I really enjoyed this project. I thought it was really fun. Um, I always like having like a physical model that I can take home after the projects, kind of like the CO2 dragster. And I didn't really have any negatives for this project. There wasn't really anything that I didn't like. I really liked doing this project. And next time, I think I would be a little bit more patient with cutting and gluing because especially for my trusses, I feel like I should have done a better job cutting them it didn't seem like they fit as well as I wanted them to when I had to assemble them together. And then for future students, I would tell them to make sure that their wood is cut perfectly because they always say to measure twice, cut once. And I definitely think that if you want to make your shed look as good as possible, you definitely got to follow that rule. And then I just need to give credit to Mr. West and my classmates because without them, my shed wouldn't have been as good as it was. Um, Whenever I had questions, I could either ask Mr. West or my classmates. They would always help me, and I really appreciate them. And then, yeah, that's it. Thank you for watching.